Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials, and my name is Tutor Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing linear momentum. Now, the word momentum means the product of the mass of a body and its acceleration. Alright, I'll use big letter M. It is a product of mass and its velocity. That is momentum. Now, according to Newton, he said that the change in impulse, all right, is always equals to change in momentum, which is mv. Impulse is force times distance, then equals mv minus mu. V is initial velocity, is the final velocity, and u is the initial velocity. I'll make t the subject, f the subject from the formula, so divide both sides by t, and we have that f is equals m open bracket v minus u over t. So this we're going to this one is from linear momentum. Please, impulse and momentum have the same SI units, and they have it to be Newton second. Newton second. Take note of that. Now, since we've been able to deduce this, let us go into Newton's laws of motion. Okay, Newton's law. Newton's law of motion. Here we have the first law, the second law, and the third law. The first law states that a body will continue in a state of rest unless there's an application of an external force. A body will continue in a state of rest unless an external force is acted on it. Please, Newton's first law of motion is also called law of inertia. Inertia of a body means the reluctance of such body to start moving. It is reluctance of a body to start moving or to be in motion. It's called inertia. Please, Newton's first law of motion is also called law of inertia. Now, the second law states that the change in rate of momentum, is directly proportional to the force applied. Is directly proportional to the force applied. I recap, the rate of change of momentum is directly proportional to the force applied, which means that I take this momentum, right? I'll say mv minus u over t. So F is equals m open bracket v minus u over t, which means that this formula I deduced initially is from Newton's second law of motion. But this one is first law of motion. Now, what about the third law? The third law states that to every action, there's opposite and equal reaction. Yes, if I should get a ball now and I throw it to the wall, it bounces back to me. The word that is me throwing it, you call it reaction. Therefore, it to bounce to the opposite direction, you call it reaction. To every action, there is opposite and equal reaction. That is for that. Now, this will now lead us to what is called Newton's law of linear momentum. Newton's law of linear momentum. Now, this law states that in a system of colliding body, momentum. Okay, see, that is. Let me just write it. I think it's good I write on the board. In a system of colliding body, momentum before collision, all right, in a system of colliding body, momentum before collision is always equals to momentum after collision. All right, in a system of colliding body, all right, momentum before collision is always equals to what? Momentum afterward collision. There are two types of collision. We have one, elastic collision. Please take note, in elastic collision, all right, in elastic collision, momentum and energy are conserved. In elastic collision, momentum and energy is conserved. A good example is the collision that exists between atoms of gas. All right, the collision that exists between atoms of gas is what? Elastic collision. And the collision that exists between two billiard balls. All right, billiard balls is a bit what? Elastic collision. And the collision that exists between gases, you say it is what? Elastic. The second one is what? Inelastic collision. In inelastic collision, momentum is conserved, but energy is what? Lost. All right, which means that in elastic collision, momentum and energy, which is kinetic energy, are conserved, but in inelastic collision, momentum is what? Conserved, and energy is what? Lost. Take note of that. It is very, very important. Now, we mentioned collision, like two bodies colliding. All right, which means that body A has its own mass and its velocity, and body B has its own mass and what? Velocity. In that note, how do we now see it? Or how do we express it? All right, you say m1 v1 plus m2 v2 is equals m1 plus m2 v. Now this v is what? The common velocity. M1 is the mass of the initial body, v1 is the velocity of the initial body, m2 is the mass of the final body, v2 is the velocity of the final body. Then this v is what? The initial velocity. Take note of that. So kinetic before or after collision, kinetic energy before or after collision is, it's usually given as what? mv squared. All right, kinetic energy is equals what? Half mv what? Squared. Now please, Newton's law of linear momentum. Who is recording? Yeah, Newton's law of linear momentum is a combination of the second and third law. All right, Newton's law of linear momentum is a combination of the second and third law. Take note of that. Now we have application of linear momentum. In what case do we apply linear momentum? One, Jet's proportion. We have two. We have a recoil velocity, and we have what? Jet engine. So these are the rockets propulsion, then jet what? Engine. Now the recoil propulsion of a gun, it is that force that the fireman experiences. Now that's that force that the fire, as if I should pull the trigger, that force that pulls me back is called what? The recoil velocity. Now please, the recoil velocity and that of the mass of the gun, you see it is what? M1 V1 equals MV. All right, M1. Okay, I can say, okay, the mass of the bullets, velocity of the bullets, the mass of the gun, and what? Mass of the bullet, velocity of the bullet, mass of the gun, then this is what? The recoil velocity. V is the recoil velocity. And please take note that gram, the mass of an object is always calculated in kilogram. If it's given in gram, you have to divide by 1000 to get what? The kilogram. So these are the applications of what? And linear what? Momentum, what? Newton's third law of what? Motion. So let's start solving questions. Let's start solving questions. It is very, very important. Now, the first one, let me say a body of mass 40 kg, a body of mass 40 kg moves with a velocity of 5 meters per second, moves with a velocity of meter per second. If the, okay, calculate the momentum if the body bounces, if the body rebounces with the same velocity, calculate the momentum. Now, I gave us momentum as, let me use this sign, please. Momentum is what? mv. Alright, from the question, mass is what? 40 kg. Now, whenever you hear rebounces, it means that it rebounds, or moves towards what? Opposite. When it's opposite, u is minus. So the mass is what? 40 kg, and the velocity was what? Which means that v is what? 5 meters per second. Now rebounces with the same velocity, it means that u is equals what? Minus 5 meters per second. It rebounces. All right, so which means that I give us that momentum is equals what? M open bracket v minus what? U. All right, v minus u, which means that momentum is equals, mass is what? 40 open bracket, v is what? 5, then minus open bracket minus what? 5. I believe it's understood. Now this v is this 5, and this minus was here, but I said since it rebounded, so u is minus 5. All right, so it means that momentum is equals 40, then open bracket, minus times minus is what? Plus, right? So this plus this, I have what? 10. All right, therefore means that 40 times this is what? 400 Newton what? Second. 400 Newton second. Take note of the term rebounces. If it rebounces with the same velocity, it is u is always going to be what? Negative. Take note of that. Okay, so let's take more questions. I think I have some questions on this phone. Excuse me. Okay, so this is a question. It's not clear. Okay, please, I forgot to give us something. Thank God I just remembered now. Now, an ascending elevator, when an elevator is going upwards, tension is always m open bracket g plus a. This is what? Ascending elevator. All right, elevator. But a descending elevator, you have it to be tension equals M open bracket G minus what? A. All right. Then when the elevator is moving up and down, it is usually T equals what? Mg. Mg. I can change this T to be arrow, okay? Arrow, arrow, tension, all right? So an ascending elevator is this, descending elevator is this. While when the elevator is just going up and down with constant acceleration, you use what? This. Take note of that. So let's solve a question. Okay, the question says, good. So, and okay, a 1000, okay, I don't know if I should write on the board. A 1000 kilogram elevator is descending vertically with acceleration of 1.0 meter per second, which means that, okay, let me write it. A 1000 kilogram elevator is descending with acceleration of 1.0 meter per second squared. If the acceleration due to gravity is 10 meter per second squared, the tension in the suspending cable is, they give us option as 1.0 Newton, B 10.0 Newton, C I have 9,000 Newton, D I have 11,000 Newton. Alright, okay, 0 Newton. So whenever I hear the word descending, look at the word descending. Whenever I hear that word descending, what are you using? You are using the word this other idiot. So you can use R, you can use T. So T is equals what? M open bracket G minus what? A. Alright, they said the tensions we are calculating for what? T. T is equals, mass is what? 1000. Then gravity is what? 10 minus what? 1. So tension is equals 1000. 10 minus 1 is what? 9. So tension now is equals what? 9,000.0 what? Newton. Alright, so which means the answer is what? This. Whenever you hear the word descending, just take your mind to the formula straight. Alright, do you get? So that is the formula. The mass is 1000. Acceleration to gravity is 10. Then the acceleration it's used to move is what? 1. So 10 this, we have this. Then this times this is what? 9,000. Okay, so that is for that. Let's solve more questions. 3. Okay. Okay, it said a spring balance. Let me write it on the board, please. It said a spring balance which is suspended from the roof from the roof of a lift, carries a mass of 1 kg at its free end, if the lift accelerates upwards at 2.5 meter per second squared. Determine the reading on the string. So they said G is equals to 10 meter per second squared. Now the word is upwards, going up or ascending. So I think that tension is equals what? Mass G plus what? A. It is very simple once you understand the formula completely. So see, the mass from the question is just 1. Gravity is what? 10. Then A is what? 2.5. So T is equals 10.2.5 is what? 10 plus 2.5. Okay, it's going to be what? 12.5 Newton. This is the fucking answer. Very easy, alright? Very, very easy. The word here is upwards. When you see this upwards, write out the formula, which is what? G plus A. Then you start calculating. Very easy. Okay, one thing is to know the formula, and the other thing is to know the application of the formula. Okay, so let's take another question. Okay, let us spring. Oh, this one is blurring. I can't see this one now. Jesus. Okay, let's take one question on recoil of a gun. I think, okay, I write on is short. I write on them, but it's short. It said a submarine gun of mass. A submarine gun of mass. A submarine machine gun, rather. They use machine. Machine gun of mass 20 kg fires a bullet of mass 100 gram due south with a velocity of 250 meter per second. What is the recoil velocity of the gun? Alright, so don't forget, I gave us that M1 V1 equals M what? V. From the question, the mass of the bullets, I gave us mg. Okay, mass of the bullets, velocity of the bullets, mass of the gun, the recoil velocity. So mass of the gun, machine gun of mass, is what? 20 kg. Fires a bullet of mass. Okay, you have it to be, so you divide by, which means that the mass of the gun, right, fires a bullet of, okay, velocity, mass of the bullet. This is the mass of the bullet, right? So mb is equals 100 divided by what? 1000. This into this into this. So I have it 100 divided by 1000. Okay? So I have, so 2 into 2. I have it to be what? That should be 0.01, if I'm not mistaken. So 1 divided by 10. Okay, 0.1, yeah. So 0.1 kilogram. Alright, the mass was given in gram. You divide by 1000 in order to convert to what? Kilogram. Okay. So the next one is due south. Okay, bullet. The velocity of the bullet now is what? That is VB is equals what? 250 meter per second. Alright, so we are calculating for V, right? Velocity of the what? Gun. So MB is what? 0.1 times mass velocity of the bullet is what? 250 equals mass of the gun 20V. Divide both sides by 20. So V is equals 250 times 0.1 equals 25 divided by 20. So 25 divided by 20 equals, velocity now is equals to 1.25 meter per second. So which means from what we've done already, so mass of the bullets is what? 0.1, then times the velocity of the bullet, which is what? 250. You have it to be this. The mass of the gun is 20. So divide both sides by 20, you have this. So this times this is what? 25. 25 divided by 20 is what? 1.25 meter per second. So please, at this point, to call it a day. I don't know. Should I solve more questions? What is the time now? How many time? Okay, I've spent 27 minutes already. So let me solve one more question before I call it a day. For this question, the way it is now, I think I'm going to be dictating it. I'm going to dictate it. Let me read it. It's a very long question, very long. All these unnecessary distractions. Excuse me, let me look for it. Okay, is the question okay? It's not too long. Let's write. A trolley. Okay. A trolley A of mass 2 kg traveling at 5 meter per second collides with a stationary trolley B of mass 3 kg. After the collision, the two travel on together with on together at at 2 meter per second. Then A, they said calculate what is the momentum of A. Momentum of A after collision. Momentum of A after collision. Then B, momentum of B. Okay, I think momentum, so A is okay. What is momentum of A before? Okay, this is before, sorry. Then B, what is momentum of A? What is momentum of A before collision? What is momentum of A after collision? Then the next one is, let's see, what is the kinetic energy of each trolley after collision? Kinetic energy of each trolley after collision. Now this is what you are going to do in this case. Don't forget that I gave you that momentum is equals what? mv. Now they said mass A, that is to say for A now, the mass is what? 2 kg and velocity is what? 5 meter per second. That is before collision. So before collision, this A moved with this, which means that this is equal, mass is what? 2 times 5, and this is what? 10 Newton second. That is this A before. That is before collision, it moved with this velocity, right? Then we said then after the collision, the two travel on together at what? 2 meter per second. Then it's a moment of A after collision. Then B, you have mv. The same mass is used, which means 2, but after the velocity which it used to travel was 3. Alright, so it is what? 3. 2 times 3, I have it to be what? 10 meter. Okay, that is 10 Newton second. He said momentum of A before collision, which is 2 times 5. Then the two move with same velocity. Okay, which is what am I doing now? 2 times 5, 2 times 3, 6. I was wondering. 6 Newton what? Second. Now they said kinetic energy of each relay after collision, which means that C, kinetic energy 1/2 mv squared of A before collision. So I'll have Ke is equals 1/2, mass is what? 2. Then after collision, they moved with what am I doing? Oh, oh god, this is a very big mistake. After collision, the both of them move on with velocity of 2. So it is 2 times 2, sorry. 2 times 2, which means 4. That's it. So it is 4. This is the velocity the both of them use in moving, okay? So kinetic energy of each trail after what? Collision. After. Alright, they all moved with, therefore A is going to be 2 squared. Right, 2 into 2. I have that kinetic energy is equals what? 4 joules. 4 joules, okay? That is my what? A. Then kinetic energy after collision of B. Okay, B is, okay, kinetic energy is equals 1/2 mv squared. mv squared. So Ke is equals 1 over 2. The mass is 3. Then which one again? You have 2 squared, right? 2 squared. So I now have that Ke is equals so 2 times 3, okay, this 4 times 3 is 12, because 2 times 2 is 4, right? So 4 times 3 is 12. 12 divided by 2 is what? 6 joules, right? 6 joules. So at this point, we'll call it a day. Thanks for watching. Do have a wonderful day. Please subscribe.